Hi there, my name is Paul Halliday, and in this video we'll be looking at how to get up and running with NativeScript and Angular. We'll be learning this together by going over to the nativescript.org website, hitting Docs, and then hitting NativeScript with Angular. So what we're going to do is follow this tutorial together. We're going to investigate all the different moving parts, and of course by the end of it we should have the Groceries application, which is the example app that we'll be building inside of this article. So if you haven't already downloaded and installed NativeScript on your machine, I would definitely check out the installation article first. This essentially looks at how you can install Node.js, the NativeScript CLI, and then of course you run the setup script on both Mac and Windows. So before following this tutorial, go ahead and do that. And just before we get into the meat of this tutorial, I do want to say that I now have a subscription plan over at paulhalliday.io. If you select the Academy subscription, you'll see that you gain access to all of my courses and upcoming future courses for one easy payment. So we're back over here at the NativeScript docs, and we want to get started with TypeScript and Angular. We start with then thinking about what NativeScript is and what Angular is. Well, NativeScript, as you can see, is a free open source framework, and we can build native iOS and Android applications using JavaScript and CSS. So this is really important because when we consider frameworks that use a web view such as Ionic, well, maybe with NativeScript you'll find that in some circumstances, or even most circumstances, you may find better performance. This does give you some layout and styling limitations when compared to HTML5, but at the end of the day, you do find that you have a native Android or iOS application built with JavaScript and Angular. So Angular, of course, is a popular open source JavaScript framework, and we write that with TypeScript, and it lends itself more to an enterprise level team. But of course, you can use Angular with smaller projects, and if you don't like Angular, you can still write NativeScript with standard JavaScript, TypeScript, and even Vue at the moment. So let's continue to Chapter 1, Getting Up and Running. The first thing that we need to do at this point is create a new application. To create a new NativeScript app, after installing the NativeScript CLI, we can run tns-create. We can then subsequently pass a template, which we'll be using the NativeScript template ng tutorial. Let's copy that. If we then paste this inside of the terminal and hit enter, we should find that it goes and downloads the NativeScript template and creates a new application. We can then cd into hello world, and this of course just changes our command line directory to be that new folder. Next, we want to run an application on our computer because this allows us to emulate the application. We can either do this on Android or iOS. To run this on Android, we can run tns run Android from that folder. Now at this moment in time, you will need to have the Android SDK and some AVDs, some virtual devices, installed. So let's run tns run Android. And what this will go ahead and do, it will add the Android platform to the project. It will then start the project up with an emulator. If you run that command and you have a device connected to your machine, it will also automatically run that on the device rather than an emulator. As always, you may find that it does take some time to boot up the emulator for the first time, but as we continue to change our application, this will be much quicker. Our emulator has started, and if we look back at our terminal, you can see it's installing the TNS Android platform. So this may take some time still. Go make a coffee, come back, and it should all be ready. So after a short period of time, we finally get the application loading up, and then we see My App on screen. Just simply has a title with this action bar here and nothing else. It's exactly what we expect, a blank NativeScript application. But perhaps what's more important is that this whole thing is native. This isn't simply just a div with a grey background and some box shadow. This is a native action bar. So I suppose the next thing to look at is of course running this on an iOS device. So you can only do this if you have a Mac computer. So we can then run tns run iOS. You will need Xcode installed, and of course you'll see that in the setup guide that we initially looked at the start of the video. So as I have no current iOS devices connected to my machine, it should initially search, but then open up an emulator. So similar to our experience with Android, we'll have to wait for the emulator to start up. We'll see inside of the terminal that it's installing the TNS iOS platform, and after a while, we should then be able to load the application on the iOS emulator. But what's more important is that any changes will automatically be deployed to the device without having to wait all this time. So it's literally just the first time that we run this on a particular platform that it takes a little while. So because we've rebuilt the application for iOS, what happens is the Android application will also restart. There should be no changes to the Android application at the moment, but as you can see on the emulator, the application is reloaded. Overall, this probably takes about 5 to 7 seconds, and you'll find that any changes that we make in the future are only that long. So we finally get the message that the project has been successfully built and is installing on the iOS device. It then opens up as we expect, but with a different user interface. So we see here on the left we have the iOS style, and on the right we have the Android style. Underneath, this is all the same code for us. We just simply use what's known as an action bar, and the action bar then of course changes depending on the platform. We'll look at this very soon, but for now let's move on to the next step of the tutorial. So we've run the app on our computer, and of course we've opened this up inside of the emulator. The next thing we'd like to do is of course look at adding some content to our app. So I'm going to open this up inside of Visual Studio Code. If we look at our directory structure, we'll see that we have folders such as app, hooks, node modules, and platforms. You may see some extra files that I currently don't. Let's go into our preferences inside of VS Code. And we can then add the files.exclude. What this allows us to do is exclude particular files from the file explorer. I've said that I want to hide Git files, SVN files, and so on, but most importantly for NativeScript development is this .js file. So we want to hide any .js file when there is a subsequent .ts file. So this means we don't want to see the JavaScript minified versions of our files. Instead, we only want to see the TS file, providing that there is both a TS and JS file available. Another thing I like to do also when using NativeScript projects is going down here and excluding node modules from the search, as well as platforms from the search. You can also do the same for Bower components if you want. So let's head over to our app.component.ts. You'll see the template for our file is currently just that action bar, and inside of here we have your UI components go here. Let's add the image with the source of the images directory /apple.jpg. So if we then check our emulator, we can see that we have both an apple on screen here on the Android and on the iOS device. The next thing that we look at inside of the tutorial is of course adding this spin keyframe. So this is what's known as a CSS animation. So what this does is it does spin the apple round in this circle over 3 seconds. So let's add this to our component. We can add the styles like so, and as you can see it targets the image, so we don't have to add any class or ID to this. Instead, if we look at our application, we can see that we have this smooth 60 FPS animation and our apple is spinning round in a circle. So already you should see something quite profound. We're able to animate and indeed style our applications here on iOS and Android with CSS. So not only are we using JavaScript, Angular, but we're able to use CSS to really change the way our applications work. So as a front-end developer, this should be really important to you because you can take advantage of native development concepts with Angular. So the next thing we have to do is add this NativeScript theme. We can add a variety of different themes, and sky just happens to be one of many. Let's add that to our app.css file. So we can import, instead of importing the core light theme, we'll import the CSS sky theme. Notice how our action bar now goes this blue color instead of the previous gray. Our challenge at this point is to pick a different color scheme. As you can see, if we select this full list and open up in a new tab, so as you can see here, we can use the core light theme, we can use the core dark theme, or we have access to these other themes. So as an example here, we could take the forest.css, and instead of using sky, we use forest, and we find that we have this green theme. At this moment in time though, we do notice now that our status bar is black, when in reality it probably should be white to match the contrast. It's something we'll look at in the future, and it's definitely something to consider as we start playing around with different themes in our application. The same goes for Android here. We don't have a status bar color at all, it's just grey. It should probably match our theme. Next up, we start talking about debugging. How do we debug our applications inside of NativeScript? So we can start off, of course, by simply adding a console.log statement. Let's add that from the constructor inside of our app.component.ts. And then the application will restart. And inside of our terminal, you can see we have that hello world message. But if you've used JavaScript before, you'll notice that if you come to log out an object, we actually get object, and not the contents of the object. So I'll use the example here. If we then try to log out, and we'll use a Redux-inspired object, such as type of log to console, and a payload of hello world. If we then check out the terminal, we should see object, like so. So what we need to do now is actually find out the contents of that object. There's quite a few ways which we can do this, but one of the easiest ways to do this is use console.dir. So let's, instead of using log, use that. Well, ideally what should have happened at this point is we should have had the correct object display on screen. And if we check GitHub, we can see that the console.dir is not working as expected compared to console.dump. This issue still seems to persist in later versions of NativeScript, and one way around this is to simply use console.log, and we'll put json.stringify, and of course we'll stringify that object. At this point, we can see our object here, which has a type of log to console and a payload of hello world. We've added an X on here for good measure, and we can then move forward to the next stage of the tutorial. So the tutorial talks about step-by-step debugging. And one of the benefits of that means that we can go through and see the values of each one of our variables line by line and add things like breakpoints and step through. If we go through into this link, you can see that we can download the extension and also check out the overview video in which you can see this step by step. It's not something we'll be looking at right now on this video, but it is something that I'll probably be making in the future. Up next, we have an exercise in error handling. So we have find the code that declares an action bar, which is on line 6 of our app component. Remove that line's final bracket so that the line looks like this. So let's go ahead and do that. And if we look inside of the console, we can see that we have template parse errors. So as seen here in the text example, we have that unexpected character which we need to add back. But another thing, because I'm using the Angular language service, and that happens to be a Visual Studio Code plugin, we get that error inside of our editor. So we can add that tag back, and we no longer have the error, and inside of our console, that error no longer exists. So let's move on to chapter 2. If you want, you can also continue down here into Appendix A and look at why you should most likely use Visual Studio Code, but there are quite a few other options available. Inside of Chapter 2, we're going to learn how we can build NativeScript user interfaces. We can scroll down and see what we'll be building inside of this video. And the first thing to do at this point is to download the new template based on this Groceries application. So we can stop this currently running project with Ctrl-C. We can cd back one directory and of course create a new app named Groceries. This will use the template of NativeScript template ng groceries. And once again, this may take some time to download and install all the dependencies. We can then cd into Groceries. At this point, we can open up Visual Studio Code once again inside of this directory. And this time, if we look at our directory structure, we have something a little bit larger. We have things like the app resources, which gives us all of the variety of different backgrounds, icons, and much more. These exist for both Android and iOS. We have pages, which represent the different pages inside of our application. At the moment, all of these files are blank. We then have a shared directory, which is going to contain our grocery service and our user service, as well as a configuration class, which is simply used to display the API URL. We also have a utilities folder, which gives us the ability to change the status bar colors. And outside of that, we have a standard app component, app module, as well as routing. The routing file is currently blank, but we'll be adding to this as we continue the video. So we can scroll down to 2.3 starting up. As we can see, starting up a NativeScript application looks very similar to a standard Angular application. We have a main.ts, and inside of the main.ts, we're bootstrapping the app module, like so, and we're using the platform NativeScript dynamic, which comes from the NativeScript Angular/platform, to bootstrap NativeScript and Angular itself. So this is quite similar to Angular's platform browser dynamic module, just a specific version for NativeScript. If we then go and look at our app module.ts, we can see that we're importing the NativeScript module, we're declaring the app component, and we're bootstrapping the app component. So effectively, all that's happening when our application loads up is that we're loading the app component, and the app component simply just has a label which says Hello World. The NativeScript module is giving us access to NativeScript specific components such as label, action bar, and a variety of other things. We'll scroll down to our exercise in 2.4, and this allows us to add new UI elements to the app component. So if we copy this and we head over to the app component.ts, we can change the template from using speech marks to using backticks. And inside of the backticks, we can paste the text fields and buttons. So at the moment we have some red lines, and that's normal because the Angular language service is saying, hey, this text field is not a known element. And that's because as far as Angular is concerned, it doesn't know what this text field is. So we need to add the no errors schema to our app module. So inside of app module.ts, we can add schemas, and we'll add no errors schema. And that comes from Angular core, so we can simply add that as well as our ng module import. And you'll notice that the red line then disappears. I'm then going to run the application on iOS only. This is simply just to save some system resources while I'm recording this video, but you could boot this up on both iOS and Android for now. If we then look at our application, you'll see that we have this button called Sign Up for Groceries. But if you remember, we also had other buttons, such as Sign In, and then two text fields. Why are these not appearing? Well, we'll look at that again in a second, but for now I want to bring your attention to some attributes that we can add to our buttons, text fields, and a variety of other elements. So our text field, for example, has a hint attribute, and that shows a placeholder text. That's similar to the placeholder inside of a standard input box with HTML. We have keyboard types, which is similar to type, autocorrect, auto capitalization type, and much more. If you look at the documentation for each element, you'll find the different attributes available. So back to why we only see this one big button. That's because we currently aren't using any layout elements. If we look at what we're essentially telling NativeScript to do at this point, is that we only want to display this last element. You could think of this inside of HTML terms, if that what we need to actually do is add this inside of a div. So our content would look similar to that. So as you can see, we'd have a div which wraps these elements. But inside of NativeScript, it's called something different depending on what type of wrapper you want to use. So let's scroll down further and look at these layouts. We have things like the absolute layout, the dock layout, the flexbox layout, grid, stack, and wrap. So I'll let you read all of these elements yourself, and of course I'd recommend playing around with different ones inside of your application. We'll currently be using the stack layout, and that's because the stack layout allows us to stack items on top of one another. Notice how the example also states that this can be stacked either vertically or horizontally on top of one another. And for forms, this is especially useful. So let's replace our example code of saying div to instead say stack layout. We can then look at our iOS simulator, and you'll see that we have this email address, this password, and the two buttons as we expect. All of the content is stacked on top of one another, but at this moment in time, it doesn't really look that pretty, and it's all kind of bunched together. Here's an example of what it may look like on an Android device. And if we scroll down, you can see that we can add a variety of different CSS terms. We can have a look at the full list of CSS properties. And if you want to, you can look at all of the different elements and maybe look at what is supported, what isn't supported, and so on. So let's go to our app.css file. Inside of app.css, let's paste in the page, which gives a background color of white, a font size of 15, the text field padding of 10, and the font size of 13 inside of that text field. This certainly looks a little better. We now have some padding in between these elements, and as the tutorial states here, it should feel quite familiar to you if you've ever done any sort of web development in the past. These are tag names. As we can see in our app components here, we are referencing this text field, but we could also add a class or an ID to the text field if we wanted to. And here's where things get a bit interesting. We can then add platform-specific CSS to either target something on iOS or Android and style it differently. So let's import this URL of /platform.css. Let's add that inside of our app.css at the top. And what this allows us to do from here on out is add both an iOS and Android specific CSS file. So inside of our platform.ios.css, let's add a text field, and that selector will have a border width of 1 and a border color of black. On iOS, we now have this border around all of our text fields. If we opened up Android at this point, it wouldn't have that styling, and that's because it's specific to iOS. As you can see here in the picture examples, it only looks at the iOS styling. But once again, we aren't specifically limited to only using platform CSS, so we can actually come down to the component-specific CSS, and at the same time, we can change the platform for that specific component as well as any common styles. So let's add the style URLs like so inside of our app component. And this is using the CSS files inside of the pages login, and then we're using login.common, and we have this login.android and login.ios. Notice though inside of the style URLs we're saying pages login, login common, and then we're using pages login, login. we don't have a CSS file called login.css. What NativeScript is doing here is it's saying, hey, any file that matches login.android on the Android platform, that becomes login.css, and the same happens for the iOS.css file. So let's paste in the common styling into the login common.css. And if we now look at our application, it looks much better. We can then, inside of our app component, add the class of submit button to the sign in button. This gives our button here a different styling in comparison to the standard button. You can see that this also is reflected on Android, like so. So we initially looked at how we can add images to our NativeScript applications. Well, we found out that we could use the images from source, like so. But we also have the ability to get images from a web URL. Finally, we can also get images from our resources. So these are platform-specific resources, and these are sized appropriately, at least it should be. So we should have an image inside of the drawable MDPI, the HDPI, the XHDPI for Android, and for iOS we should have things like the standard definition. Then we should have the 2x and 3x respectively. These allow us to appropriately show the correct image across a variety of different devices. So let's add this image. We'll take it and add it as a child of the stack layout. Notice how we're applying the stretch none attribute to this image, and we're aligning this image in the center of the stack layout. We now have a form, we now have some images and review styling to change the way our application looks. Let's hit chapter 3, application logic. We'll start off inside of this chapter by adding a tap event handler to a button. So here inside of our app component, let's add a tap, and that will be pointed at the function submit. And inside of our app component, we can then add the submit function and simply log out hello. Before we logged in the console whenever we wanted to see a console log, we could do the same here if we hit sign in multiple times. We then see hello multiple times inside of the console. So this is how we can start wiring together some business logic and react to user click events, or indeed tap events, from within the application. We're now going to look at data binding and alerts for the first time. Let's add an email to our application. Instead of using console.log, we'll add an alert with backticks and say you're using, and we'll pass in this.email. What this should then do is alert you're using NativeScript rocks at telerik.com on the screen whenever we hit that submit button. Let's go ahead and hit sign in. As you can see, we're given an alert like so. Next we want to look at data binding. So inside of our text field, we want to set the text of our text field here, so the email field. And if we wrap it in these square brackets, this allows us to bind to the email attribute. So here the email property inside of our app component is equal to the NativeScript rocks email. And then we're binding this text attribute to the email property like so. So if we look at our application, we then see our email inside of the email box. If we add something to this, you'll notice that we don't get that two-way data binding. This is because at this moment in time, we're only using a one-way binding. Let's take advantage of two-way data binding inside of Angular. That can be done by replacing the text with ng model. So the ng model will automatically bind the value of text to the email. But you'll notice if we save the file and we reopen the application, this doesn't work. And this is because we need to import the NativeScript forms module. Let's go over to appmodule.ts and we'll import from NativeScript-Angular/forms, and we'll take the NativeScript forms module. We'll then add this to the list of imports, like so. Once we then refresh the application, we should see the email inside of the box. And if we make any changes to the email and hit sign in, we get a different email inside of the alert. This is known as two-way data binding and is accomplished with ng model. A good example of using one-way and two-way data binding is when we come to changing the values of our buttons depending on whether the user is logging in. So let's copy these two buttons here and replace it inside of our app component. And we'll also copy the app component like so. So let's run through what exactly is happening at this point. We now have this is logging in boolean. Initially we set this to true, and whenever we click this button, which is either sign up or back to login, it toggles the button from being true to false and false to true. So we're then using what's known as a ternary operator to display either sign in or sign up depending on the value of logging in. So let's take a look at this. If we hit sign up, you'll see that we get sign up as the primary button, or back to login here, which then toggles the value of is logging in, like so. As we don't need two-way data binding for this, we're using the text property, like so. We can then start thinking about how we can implement the login functionality and start routing the user between different pages. We'll start off by heading over to the shared user.ts file, and we'll add the user class. This gives us the ability to have a user with an email and a password, and we can capture that inside of the form. We can then import from our shared user/user, and that gives us access to that user class that we just created. We can then create a new property on the class called user of type user, and when we start our app component, we can create a new version of that class. So that's a new instance of that class, which we can then bind these elements of user into this text field. So instead of having the ng model equal to email, we can set that to user.email. We can also copy this and add that for the second text field, but instead user.password. And at this point, we can capture both the user and the password. As an example to this, let's set the user.email equal to hello@paulhalliday.io and the user.password to 12345. And when we refresh the application, you can see that we then have the username and password filled out on the form. This is the advantage of using two-way data binding and ng model with that user class. So anytime we add something or remove something from this form, that user object is then updated. Let's remove that for now. And another thing at this point, we do find that the template is getting quite large. In these circumstances, it's always a good idea to abstract this out to another file so it makes this component much smaller. Let's take the entire template and cut the contents. We can then add this into login.html, and inside of the app component, we can set the template URL to be pages login.html. If we save that and our application restarts, you should see that everything looks exactly the same as it did before. The next thing we'd like to do is start authenticating a user with a backend. So we're going to head over to our userservice.ts and we're going to create that new user service. Let's paste in the service and we'll explain exactly what is happening at this point. So every service that wants to use a constructor and inject dependencies inside of Angular needs this injectable decorator. Add that to your service at the top. Then we're importing the user class because we'll be using this throughout the service. We're then exporting a new class called the user service and exposing a method here called register. It takes in a user, and we can also just refactor this at this point and say username user.email and passwords user.passwords. Obviously, in production applications, it may not be a good idea to at least alert passwords on screen, but for our example, it should be fine. We can then head over to the app component or the app module.ts. We need to inject this provider and tell Angular that we want to use this service across the application. It perhaps seems that this tutorial is only using the user service inside of the app component, so let's add a providers to our component. And from here on out, we can inject the user service, and that comes from shared user.service. We can add that to our providers like so. And if we want to use this service across the application, you may want to add this to the app module instead of the app component. We can then inject this into the constructor by saying private user service of type user service. And what Angular does at this point is it creates a new version of the service and handles the dependencies for us based on the type of the service. We can then take the submit function. We can paste over it with the new function, as well as using login and sign up. So let's look at exactly what is happening at this point. We're able to now either log in the user or sign up the user depending on the context of whether the user is logging in or not. So we're using that one function to handle both of those events. If the user hits the sign up button, we are going to call out that user service and the register method, passing in the user here as a parameter. We can then add an email address here, such as e@e.com, and the password of 123, and hit sign up, like so. You can see that we have alerted that user object, such as the username and password, on screen. Now at this point, we want to start thinking about how we can authenticate that user based on the fact that they want to sign up. So let's copy the next phase of the tutorial right here. Let's hit copy. And we'll head back over to our user service.ts. We'll paste over the previous code. And in a moment's time, we'll take a look at exactly what is happening. First, I want to take the signup function right here, and we'll paste it inside of the app component. So instead of using the register method like this, we'll paste this in. And we'll go step by step and see what exactly is happening here. So we'll start off at our user service.ts. As you can see here, we're using the HTTP module. We're importing HTTP headers and response. This here is the old HTTP client. If you want to use the newer HTTP client, you may want to look at Angular Common, HTTP, and the subsequent documentation with that. Next, we're importing the RxJS observable, as well as the do and map operators. We're also then at this point importing our user object and the config that we looked at earlier on in this lecture. That contains things like the API URL. And inside of the user service, we're then instantiating a new version, so we're injecting this HTTP module. Then inside of the register method, we're creating some new headers, and we're appending the content type of application JSON. So essentially, we're using the content type application JSON for this request. We're then making a new HTTP request that happens to be of type post to our config.api URL. And we can make this use backticks to make it read a little bit better. So we want to simply use the API URL, and then we'll add users after that. We can then stringify the content so that it can be appropriately posted. We want to use the username, email, and password, and pass along any headers. In this circumstance, these are the headers that we created earlier on. We then want to catch any errors, and the catch function at this point simply will just log out the error and throw an observable of error. So if we look at our application, we then have no provider for HTTP. So if we scroll further down inside of the tutorial, you'll see that this is remedied by importing the NativeScript HTTP module. Let's go ahead and do that. inside of our app module.ts. And we can add this to the imports. And then our application starts up without error. But we haven't looked at the app component.ts. So let's see what this does. So we then have an observable that is returned from our HTTP post. We're then subscribing to this observable, and we can think of these as the next event, and here as the error event. We aren't passing any parameters down, so this is simply just thinking of it of how an observable works. An observable does three things, and it gives us the ability to either have a next event, and that's when something has successfully been created, and we push the next value inside of the observable. So we have your account was successfully created. We have an error event, which happens if we catch any errors. It's passed down here, and we get the unfortunately, we're not able to create your account. And finally, we'd also have a complete event. And that happens when the observable has completed. So inside of our application, let's now take a look. We'll make a new account, and we'll just use a random account for now. And we'll hit sign up like so. And you'll notice that we get this error. We get, unfortunately, we were unable to create your account. So what I want to do is then look inside of our console. We get the message here, which is a user with that name already exists. So let's change the name to be something a bit better. And hit sign up once again. And it looks like we got the same error, so the username already exists. So surely this one can't exist if we hit sign up once more. It looks like it does. So let's maybe try something different. Perhaps if we try test123 at test123.com, that apparently still exists. So I'm going to add some Q's on the end, and surely that can't exist. And we finally got there. Your account was successfully created. So we now have an account, albeit it's quite long, test123, and 4 Q's at test123.com. But what's more important is that now we've made a HTTP post request. And of course, at this point, we're not really concerned about this complete event. That was just simply for demonstration purposes. But you'll see that when we do have an error, we do alert. Unfortunately, we weren't able to create your account. But because we were successful, we do then get your account was successfully created. So we now need to think about logging into our backend. Let's make it easier on ourselves, and we'll hard code this so we don't forget our credentials. So ours was test123qqqq at test123.com, and the password was 123456. At least that's what I think it is. And we'll continue down and start investigating different things such as routing. So routing allows us to send the user to a different page depending on a particular event. So maybe when we've logged in from this login page, we want to send them to the list page. That's done with routing, and we're going to look at that in 3.5 and on. So we want to take everything inside of the app component, and we want to copy that instead to be the login component. So let's take everything here and Command X and paste it in the login component.ts. Let's rename this to be the login component. And inside of the app component for now, we will simply put a template that contains the page router outlet and the selector of main. We'll look at this in more detail as we continue through 3.5, but essentially what this is going to allow us to do is put the content of any page that we've navigated the user to inside of this element. So this means we then have this single page which is injecting these different pages depending on where we route the user. But let's not jump ahead too much. So let's go and copy the login component route into the app routing.ts. What we're doing here is importing the login component. We're exposing some routes, so saying the default route here should be this component of the login component, and then we're also exposing a constant to be used later called the navigatable component, and we're passing through the login component. We then need to head over to our app module.ts. We want to import from NativeScript Angular /router. We want the NativeScript router module. And we need to give our application some default routes. Let's add the NativeScript router module .forRoute, and we want to pass through the routes that we just created. So let's import both of these things from app routing, the routes and the navigatable components. Let's add routes. And we now have these navigatable components. So anytime we have any declarations, what we want to do is use the spread operator and spread over the navigatable components. And what this will allow us to do is take each one of those components inside of the navigatable components array and add it to the declarations. So anytime we want to add a new component to the declarations, we simply just add it to this navigatable component. Next up, let's add ourselves a list component. So let's head to the list component.ts and paste in a very standard component. Inside of list.html, we can give this a label of hello world just so we know we've navigated to this component in the future. And at this point we can go back to our app routing, and to add a new component to this, all we need to do is effectively add a new path and at the same time expose that component inside of this array. So let's do that by updating the routing file. Like I said, we're simply just pointing the path of list this time and giving it the component of list component. So we've made a lot of progress, but now we want to allow people to navigate and log into our application. So let's head to userservice.ts, and at this point we have a register file or a register function. And what we'll do is just close that down a little bit for now, and we'll add a login function. This is very similar to the register function, and we can simply put this using backticks like so. So what exactly is happening at this point is we are then of course setting the content type to be JSON once again. We're making a post request, this time to a different URL, passing the username, password and the grant type. We're then mapping over the response and returning the JSON elements of that response. If we use the HTTP client instead of the standard HTTP module here, we wouldn't need to do that. But after that we're using the .do, and what do does is just goes over this once, and what it'll do is set the config.token to the result of our access token from that response. So if you remember, this is a static property, so it'll be the same across any instance of config. And by instance I just mean this class. Finally, once again, if there are any errors, then we'll handle any errors and return an observable response. Like so we'll just simply throw the observable. So this now gives us the ability to log a user in, providing they provide us a username and password. So we're nearly done. What we need to do now is import router inside of the login component. So let's head over to the login component.ts. We also need to update our paths because we have changed our component. So add // shared. And we want to inject a private router of type router, like so. And then for our login function, as we're still waiting to define it, we can paste this in. And exactly what's happening here is we are going to the user service, we are logging in, we're passing the user object, we're then subscribing to the response. If we successfully log in, then of course we want to navigate that user to the list. And if there are any errors, then we want to log out that error. I do want to fix our register function at this point because by saying next, we are sort of implying that there is a return here when there's actually nothing. So let's take a look at this. If we then hit sign in, we then of course navigate to that list component. So at this point we are actually authenticating a user. At the same time we are signing up a new user if we click that sign up button. And then once we're sure that we have the correct user, we're then navigating that user to the correct component. So on to chapter 4, NativeScript modules.
Oh, this you crazy mother.